Hello, students. My name is Sonia Malik. I am your coding teacher and mentor. So, in this lecture, you will be getting to know about advantages of arrays, applications of arrays, and disadvantages of array. Hello, students. In this lecture, we will be covering more concepts about arrays, right? Okay, so let us start. So, in this video, we will be covering advantages of array, applications of array, and disadvantages of arrays. Okay, so we will be covering all of these concepts, and believe me, these are very important to know, like where array should be used. Like, these concepts will tell you where to use arrays and where to use other data structures and not arrays, right? Okay, so let us start with advantages of array. So let us move to the open board for this topic, right? Okay, so first topic is advantages of arrays, right? Advantages of arrays. Okay, cool, awesome. Okay, so let me give you some array. This is zeroth index, this is first index, this is second index, this is third index, this is fourth index. Okay, so suppose this is 20, this is 10, this is 20, this is 30, this is 40, this is 50. You can take any elements, right? Okay, so the first advantage is random access. Okay, so with arrays you got a superpower. You do you want to know like what superpower it is? It is index, right? Like in your class there are so many students, and when attendance is taken, the attendance can be quickly taken by just picking roll number 1, 2, 3, 4, like that. Okay, so these are the roll numbers of array elements, basically. If to be talking about generally, talking in general terms, then these are like roll numbers. Okay, so random access, array provides random access. It means if we know the index of a number, we can easily access that element. If we know the index, then we can easily access the value at that index. You want to see how? You want to see how? Okay, suppose I am giving you some index. I am saying, hey student, please access the value at index number 3. Please access that. So you will simply do like this: see out ARR, where ARR is the name of this array, ARR index. I gave you index. You easily accessed the value at that index by just writing this line. ARR index, it means value at that index. Okay, so this is the first advantage, that we can randomly access. We can access this one index element, first index. We can access this second index element, third, fourth, and so on, like that. Okay, so random access is provided by the arrays. Okay, so let us move to the second advantages quickly. Okay, okay, so suppose if I'm asking you, suppose this is a teacher. I explained you this example previously also, right? So this is teacher and this is student. This is student, this is teacher. So teacher is asking student, hey student, can you give me 10 students roll numbers? 10 students roll numbers, roll calls. He will say, okay ma'am, give me 5 minutes, I'll bring that. Okay, now this student, this is the monitor, he is the monitor of the class. Now you know like what it will do? It will create 10 variables. Int A, suppose roll number 10, int B, roll number 11, int C, roll number 12, so on, int J, roll number 20 or 19, something like that. Okay, so for this task, for the completion of this task that is given by his teacher, he created 10 variables, which is a very tedious task. Tedious task. Tedious means time consuming task. Very boring, very time consuming, and unnecessarily we are creating 10 variables. Okay. But arrays provide us this facility. Arrays provide us this facility that we can store similar data type in some array in it. Now, instead of creating these 10 variables, for storing 10 roll numbers, we can simply create an array of size 10. Am I correct in saying that? Yes. I am creating an array of size 10. Okay, and I am storing these 10 roll numbers here. I am storing these 10 roll numbers here. Okay, this is 19. Okay. 19. Okay. Now student or the monitor will carry this array to and give it to the teacher. Right? So this is the another advantage, that instead of creating so many variables, we can simply create an array of size 10. We can simply create an array of size 10. Another is, suppose teacher is asking you, get me okay, give me 50 names. Give me 50 names. Student will again create 50 string variables. Name 1, string name 2, name 2, so on up to string name 50. 50 variables for 50 names. But what if he would have created some array of size 50? Int ARR. No, not int, string ARR, because it is a string array. String ARR, size 50, and stored all the names in this. Karan, Varun, Shaleen, stored the name in this. So this is good idea, right? This is not tedious task. One-liner task it is. But it is occupying 50 lines. Or not lines even. But it is a tedious task or time consuming to create 50 variables, right? Okay, so this is a second advantage of array, that we can create array instead of creating so many variables of different data types, right? Okay, these are the mainly two advantages of arrays. Now let us move to the applications of arrays. Applications of arrays. Right? Okay, so this is the application. These are in this we will be writing applications of array. So first application of array. So what is the first application of array? It stores data. This is the first application of array. Like as you have seen in the previous advantage, it has stored 10 students roll numbers, 50 students names. So it stores data, but of similar type. If there is an integer array, it cannot store string or character or float value. Okay, so similar type. It stores data. This is the advantage. This is application, but of similar data type. Similar type, right? So this is the first application, that it stores data but of similar type. Fine. Okay. So what is the second advantage? What is the second application? What is the second application? Arrays are used if the size is known. Okay, we will be talking more about this point in the later part of this video, because I have to emphasize it more clearly, right? But for now, let us understand arrays are used when data size is known. Okay, so because you have to allocate some size and then create the value, then create some array. Okay, that like this. I have taken size as 5 when I am creating an array of size 5. Okay, if I'll store one more element now, then it will not give 6. It will give some error. It will say that you have allocated the size as 5 and now you're storing 6 elements. So for using arrays, the size should be known already. The size should be known already, right? So this is a second advantage of array. Sorry, application of array, right? This is a second application of array. Now, what is the third application of array? What is the third application of array? It is used in solving matrix problems. Matrix problems. We will be covering this matrix data structure in the later part of this course, right? Very soon, very soon. Okay, but later part after arrays and strings like that. Okay. So what are metrics basically? Metrics are two-dimensional arrays. Metrics are two-dimensional arrays, right? Two-dimensional arrays. It means something like that. Something like that. You have seen some chessboard, na? Chessboard. That chessboard is a two-dimensional array, right? Chessboard. That chessboard, carom board, it is a two-dimensional array. Mainly the chessboard, right? Okay. So this is a matrix. We will be covering it later, like what is a matrix data structure. But for now, understand this point only. Like it is used in solving matrix problems. Can you think in your mind like how array can be used in solving matrix problem? Array looks something like this. Array looks something like this. Okay, this is array. You know not that like this is the array. How can you use it to solve complex or solving matrix problems? If you see carefully, the row, you know, no, these are the rows. The rows are the horizontal lanes, and these are columns, vertical lanes. Like you know, no, this thing. Okay, rows and columns. If you see carefully, matrix contains four arrays. This is array 1, this is array 2, this is array 3, this is array 4. It is nothing but an array. It is nothing but an array. This is array 1, this is array 2, this is array 3, this is array 4. Can you think like this? Can you think like this is appearing same as this? It means a matrix consists of so many arrays joined together horizontally or in a vertical fashion, right? So every row of some matrix is same as the array. So can you think now that array can solve the problem? Because we can assume these rows as an arrays. Now can you think this in your mind, like how arrays can be used to tackle matrix problems? Because matrix is nothing but collection of arrays. Matrix is nothing, this is matrix, it is nothing but collection of arrays. There are four arrays. Okay, so whatever operation we are performing on this array, now we can perform this, whatever operations we are performing on this array. Okay, so whatever operation we are performing on this array, we can perform those many operations on the rows of this matrix, because these rows are like arrays only. So this is how arrays are used to tackle matrix problems. Because how you solve array problem, you can solve matrix problem quite the same way by assuming it as four arrays: array 1, array 2, array 3, array 4, right? That's why it is said that arrays can be used to solve the matrix problems. Now, what is the fourth application of array? What is the fourth application of array? Different variables, different variables can be saved under one name, or stored, more probably stored under one name, under one name. This is very crucial point actually. This is very crucial point. Let me raise the above part so that I can explain this part. Okay. Different variables can be stored under one name. What do you mean by this? Earlier, if you're creating three variables, you are giving different names. A, int B, int C, different names. But when you're storing these three variables in some array, with some index, you're storing some variables. Suppose this is 10, this is 20, this is 30. This is 10, this is 20, this is 30. Now you're not using three variables, you're using one array, okay? This array name is ARR. Earlier you were calling this 10 as A, this 20 as B, this 30 as C. But now you will be calling this 10 as ARR of 0, 20 as ARR of 1, and this 30 as ARR of 2. So, with one name, what one name? ARR. With this one name, they all are stored with this ARR name. So that's why it is said that different variables can be stored under one name. With one name, what is the one name? ARR with some index value. Otherwise, earlier they were ABC, but now 10, 20, 30 are not ABC. They are ARR 0, ARR 1, ARR 2. So is the fourth application clear? I am assuming that the fourth application is clear to you. Let me rub it off. Okay, fine, cool. Interesting, yes. So this is the fifth application which we will be covering up for now, right? Okay, okay. So, so array data structure, or basically I should say like this, I should say it like this. Database uses array data structure to store records. Like there are many databases. There is MongoDB, there is some other MySQL, right? And Oracle note, I'm not sure. Okay, so there are so many data structures, so many databases. Yes, Oracle might be. I'm not exactly sure about Oracle, right? That's why I am erasing its name, right? Okay, MySQL, MongoDB, SQL also. So these are the databases, right? MySQL is the database. This is query language SQL, right? Okay. So this if this MongoDB stores data in some form, this database stores the data. That database stores the data, whatever it gets from the application. There is a login page. You are asked now when you visit an application, username and password. This is getting stored in some database, right? We will be covering this topic later in the session after covering data structures, right? Okay. Okay, so data is stored here, and this is also a database, MySQL, and data is stored here. So there are some databases where the data is stored in the form of arrays. Okay, data is stored in the form of arrays. Like it can be something like this. Let me erase it off and show you how. It can be something like this. Suppose there are 5 users which we have asked their name and age. There are 5 users from whom we have asked their name and age. So it can be like 2 arrays are created in the database, and here the name can be given. Name can be given 5 name, and then corresponding their ages. Suppose X, Y, Z, L, Q, something like that. Okay, so name and corresponding that name, the person's age. This is how data can be stored in databases. Some databases, right? Not everybody, like every database has their different form of storing the data, but some databases can store the data in arrays. Okay, in form of arrays, right? Name and then corresponding that name, person's age is there, right? So this is also one of the application of arrays. Clear? Okay, fine. So what is the sixth application? Of arrays? Array data structure, array DS, can be used for sorting algos. Can be used for sorting algorithms. There are many sorting algorithms like bubble sort. We will be studying each one of them in the later sessions, right? Bubble sort, insertion sort, selection sort, merge sort, and quick sort, and many sort like count sort, bucket sort, radix sort, cyclic sort, like things like that. And as per my experience, I have done all these type of sorts in my coding journey. So these all uses array data structure. These all uses, this also use array data structure. This also every sorting algorithm, almost every sorting algorithm uses array data structure to perform operations upon it, to perform operations on it, right? Okay, so this is the application. This is another application of arrays, that it is used to perform sorting operations. It provides array is provided to sorting algorithms to perform operations upon, right? Seventh, okay, seventh, okay, so it is used in implementation of higher data structures, used in implementation of higher data structure, of higher data structure. It is used in implementation of higher data structure. So in future you will be using these arrays to implement linked list data structure. This is very new term, I think, for you, but we will be covering it after strings, right? Don't worry, we will be touching every aspect of it. So it is used to create this is higher data structure as compared to linked list. Okay, so linked list is used to implement this arrays are used to implement this linked list, right? Arrays is used to implement stack is some kind of data structures, like you go to marriages now. Okay, so let me give you some hint about these data structures. Like we will be covering thoroughly all these data structures in the later sessions, right? But let me give some example. So arrays is also used to implement this stack. Okay, and array is used to implement queue data structure also, queue data structure also, right? So it is said that used in implementation of higher data structure, these are higher data structure, this is quite basic, these are quite higher. So higher data structures in which array is used to get to implement these high data structure, right? So I was giving you example of stack, let me give you some example of stack. Okay, let me give you some hint like what stack is all about and what queue is all about, right? Okay, stack, just some small hints so that you can think like, okay, array can be used to implement these data structure, right? Okay, so when you go to marriage hall, you see na, like there are stalls like that. There are some fast food stalls, chow mein, golgappe, like that, sandwiches, something like that. Okay, a rabdi, something like that. Okay, so and there are a salad. There are salads in some tray, and there are some plates. These plates are stacked over one another. Stacked. Okay, plate is kept here. Some plate is kept here. Then plate. Okay, plates are kept like this, na. If you remember that plates are kept like this. Okay, so this person will come. He will pick this plate and remove it because he want to take the food from the stalls, right? Then another person will come, he will take off this plate. Okay, then it is rubbed, erased. Then this person will come, this will take third plate. Okay, so in stack also, like these are the elements are only inserted from top and deleted from top. Okay, you can insert whatever you want, like there is stack. If you suppose by mistake you have taken two plates, okay, you want to keep that one plate. Suppose your mother already have taken some plate for you and you have also taken some plate for yourself. So your mother will say, hey son, I have taken a plate for you, don't take it. So the son will go and keep that plate on this stack. It means insertion, the plate is inserted back on the top and it is removed from the top by other people who are coming to marriage hall and for and eating the breakfast or lunch, whatever it is, right? So it is stack. It means the plates are stacked over each other, they're arranged as a stack, right? This is a stack. We will be covering it in deep when in the later session. Now next is queue. Okay, next is queue. So now you're thinking like, why arrays is used to implement stack. Suppose this is stack. It is 1, it is 2, it is 3. This is stack. ठीक है, element is inserted on the top and it is removed from the top. Now if this is an array, this is an array 1 2 3 4 5. If you lift this array from this and make it stand at 90-degree angle, this will look same. Let me pull this array from this side. Let me pull this array. Let me pull this array up and make it stand at 90 degrees. So this array will be something like this: 1, 2, 3, 4, 5. And when I again like what to say on this? Okay, so let me draw the diagram more clearly first. Till then, I can think of some exact word to what to say, right? Okay, so this is some array, right? This is 1, 2, 3, 4, 5, and this is some stack. Stack looks like something like this. 1, 2, 3, 4, 5. Okay. So when you will lift this array at 90-degree angle, this array will look something like this. Look something like this. Can you maintain? Can you guess the similarities between these? Now, are they looking like same? Yes. It means arrays can be used to implement stack. Okay. Arrays lifted to a 90-degree angle to make it in a vertical fashion. It becomes a stack. When it is again put horizontally, it is lifted now, so it is again put horizontally. It will again become like this: 1, 2, 3, 4, 5. Okay, this is how arrays can be used to implement stack, because it's just a rotation of this array that is forming this stack, right? So that is the explanation for this point, for this application, right? Now, what is a queue? Like how an array can implement a queue data structure? Like, what is queue exactly? We will be covering, again I'm saying, we will be covering it in deep in the later sessions. But for now, let me give some hint. Okay. So okay. So it is a railway station scene. Railway station scene, right? Trains are here on the platform number 1, platform number 2, platform number 3, right? Like that. Okay, this is a bridge and these are stairs, something like that. Okay, now this is ticket counter, TC, ticket counter. Yeah, ticket counter. Okay, this is ticket counter, and persons are standing here, one after the other they are standing to collect the ticket. This will go and will say, okay, I want to go to Ambala. Then ticket will be, he will get the ticket and he will be moved, because his job was done. He wanted to take the ticket of Ambala and he has taken that, and then he will move. Now second person will come. Okay, I want to get a ticket of Delhi. Then after getting ticket, he will also move. It means it follows a principle which is called as FCFS, first come first serve. It means who will be standing at the first, he will be getting the ticket of Ambala first. Second person will get the ticket at the second number. Third person will get at the third number. If some person will come and try to be here in the line, these will argue, oh, why are you coming front? Like, why are you coming on the front? Because we have been lined up from last 30 minutes and you just have came and then you are being inserted in the line. This is not fair. Move back, move back. It means those who will come first, they will take the ticket and move out of the lane. Come, take ticket, move out. Come, take ticket. This is queue. It means this person is coming and then it is going. Then this next is coming, the next is coming. This is a queue. This is a queue kind of data structure, right? So array is used to implement this queue kind of data structure. Okay, to be emphasizing more for 1 minute, let me give you some technical example. Suppose this is a queue. Okay, queue looks like this only, right? So deletion happens from this end and insertion happens from this end. Why I'm saying this? Deletion is happening from this end and insertion is happening from this end. Like this was a ticket counter, and these were several persons. So When this person is taking ticket of Ambala, after getting the ticket of Ambala, he was moving out of the lane. Then the turn of this next person will come. Okay, and if some new person will come, if this new person will come, he will be at the back here. And if another new person will come, this person will be at the back. Whatever new persons will come, they will be adding up at the back. That's why I'm saying that deletion is happening from starting and insertion is happening from back, because new persons will be added up at the end of the lane. New person, it is happening this happens in the real life now. And then this person will take the ticket of Humal and go get deleted. Then another person will come, take ticket, deleted. Another person take ticket, deleted. That's why I'm saying that insertion is happening at the starting and deletion is happening at the starting, insertion is happening at the back. Okay, so arrays are used to implement a queue kind of data structure, right? When I use similar color sketch now, it becomes very messy, like mix up. That's like I used this now. This is not getting differentiated, like where deletion happened, where this. So this person will come, take the ticket and move out. Then this will come, and new persons will be added at the back. New persons will be added at the back. Okay, it means deletion is happening from front, deletion is happening from front, and insertion is happening from end. Okay, okay, cool, fine. Okay, now okay, so fine. So these are some advantages of arrays. These were some advantages of array, and they were more advantages. I'm not telling you about more about this at this point of time. It is very can be very confusing for you. But let me tell there, it is having some eighth application also, and this application is, you know what? This arrays are used in operating system concepts as CPU scheduler. Okay, CPU is central processing unit, right? Central processing unit. So CPU scheduling. You know, it is giving something like that idea. Like I'm not like at this point of time, if I will be explaining you this thing now, it will become very confusing for you. So when we will be studying operating system concepts, then we will be tackling like how arrays are used. But CPU is a resource and every app wants to consume it. This is TikTok, suppose TikTok, PUBG, WhatsApp, everyone is consuming this resource one by one. So they are aligned in some arrays. Okay, when this will come and consume it, when this will go to some preemption, something like that, this will come. Okay, so this is something, some kind of scenario. Okay, we will be discussing at it later in the operating system class, right? Okay, so these were the some 7 to 8 applications of arrays and 1 to 2 advantages of arrays. Now let us move forward to the disadvantage, because every coin has two sides. If one is having some advantages kind of thing, it might also be having disadvantages also, right? Disadvantages of array, like when if we will be when we will be studying disadvantages of array, how it will be helping us, like why we are studying about advantage disadvantage, because when you come across some question, then you will be when you will be studying all the data structures. Now suppose there are 25 data structures and algorithms mix. Suppose there are 18 data structure and then some 7. Suppose I'm saying, I'm not exactly in like counting it up. Okay, so this is algorithm. So after studying all, when you will see a question now, you will get multiple thinking in your mind. Like you will say, okay, it can be done with array, it can be done with string, it can be done with recursion, it can be done with linked list. You will think like that. And when this question will come, you will think, okay, what approach to use. You will getting confused because you have studied every data structure algorithm. Now the question come and you have to think in your mind like what to use. So if you are aware about disadvantage and advantages of array, na, you can think, okay, here the array can be acted and can be acting as an advantage, so let us use it. So here the array is acting as disadvantage, so not to use it, instead use linked list. Okay, instead use linked list. You will feel automatically this thing when you will be solving question, that arrays cannot be a fit, linked list can be a fit here. So that's why it is very important to study the advantage and disadvantage, so that you can know like what data structure to use when. If you know that, and in this, in some question there is array is performing as a liability and not an asset, then you will not be using this array. So disadvantages of array. Okay. Okay, disadvantages of arrays. Fine. Okay. Cool, cool. So now the first disadvantage of array is the first. Um. Okay. So the first disadvantage of array is that it stores, it allocates size. It allocates size at the compile time. Compile time. Compile time. It allocates size at the compile time. It means it performs static allocation. Compile time allocation means static allocation. Allocation. You know, like, what do you mean by this line? Or I can say in another form that size is fixed. Size is fixed. Or if another term I can say size is not flexible. Size is not flexible. Flexible. You know, like, what do you mean by flexible? Who is ready to accept with the changes? Like, if there are three elements, I am adding fourth element, that it is not easily accepting this fourth element. It will give some error, like, oh, you have given size of 3, why you are giving the fourth element. So it is not flexible. Like, flexibility is some characteristic of humans also, who are ready to accept the changes. They are flexible. They're not fixed, like they are not having fixed mindset. They are very flexible. If they are say, if some situation come that you have to go to Bangalore, then they will say, okay, I'll shift to Bangalore, no problem. I will shift to Delhi, I'll shift to Noida. Okay, but some are having some fixed mindset that they're not ready to accept the changes of the environment, right? Okay, so flexibility is also the human characteristics, right? And it is also the characteristics of arrays, because array can be flexible. Array is array is not flexible. Okay, array is not a flexible data structure. Array is not flexible. Array size is not flexible. It is not ready to accept some new element getting added up. It is fixed size. If you are given size 5, you cannot allocate 6 elements. It will not take it. It will give some error or store some garbage value in the sixth location, something like that. Okay. So it is allocating memory at the compile time. It means we have to mention earlier, okay, this is the size of array. Int size is equal to 5. We have to mention while while coding up the arrays, we have to mention, okay, the size of array is 5. And when we have to suppose add the element, suppose case, okay, suppose this is some array, this is some array. Why it is not flexible? I am emphasizing about these points, this first point, like why it is storing compile time, static, fixed, flexible. Suppose I have given size as 3, size as 3, and okay, let me erase this board off, because it will take more space of the board to explain this part, right? Suppose this is the size. Suppose this is an array. Suppose this is an array. 1, 2, 3. 3 elements are stored in this array. This is 0th index, this is first, this is second index. Okay. These are the indexes, right? Okay. Now the size is 3. I have predefined the size as 3. Okay. Now if I want to add a fourth element, it is not flexible to take this fourth element. It will say, it will give some error. You know, like, what error it will give? I have shown you in the previous sessions also. It will say, like, your size is 3, then why are you, like it is not actually saying like this, why are you adding, but this is my tone of saying, but it will say in some technical language that size is given 3, but you are giving an extra element. Where I will store it? Because I am not having an extra block. Where I will store it? Where I will store it? I am not having an extra block, because the size is 3 and I am storing 3 elements. Where I will store that for? Suppose the size is 3 and I am storing 2 element, and then you are asking add this element, then I can easily add because I have one extra block. But now the size is 3 and you are saying me to add one more element. I cannot add. Sorry, I am fixed. I am fixed. I am not flexible like you, right? The array will say like I'm not flexible to take that change of my size. I'm not flexible in, like I can't take this, right? I can't take this fourth element to get added up before after this third element, right? So that's why the first point is saying array is not flexible. Array is not flexible. Array is not flexible, right? Okay, it cannot take one more element. Now what is the solution of this problem? What is the solution, how to overcome this problem? Like we genuinely want to add this fourth element, but we are not able to add it up because the size is 3. You have two choices you are having. Either create a new array of size 4 so that this fourth element can be taken up, either change the size or increase the size of this array from 3 to 4. These are the two options. Either take a completely new array and transfer this one here, this 2 here, this 3 here, and whatever new element is getting added up, transfer it here. This is one option, that create entirely new array. Create new array. New array. Create new array. Second option is that resize this array. Resize the previous array to one more block. It means change this size n to n plus 1. Earlier it was 3, change it to plus 1, it will become 4, then I can take. Then I can take that fourth element because the size is changed. But it is not flexible in taking that element. Okay, because it is not flexible. It is static, it is fixed. Either you have to create a completely different array, completely bigger array, or you have to change the size of this, you have to expand this array. So these are the two options, but it is not flexible in taking newer elements. So that's why I'm saying that it is fixed. Okay, so what is the second disadvantage? So this is the first disadvantage, and now how to overcome this disadvantage? In order to overcome this advantage, you can use some other data structure like linked list, because in linked list there is no issue of adding there's no issue of size. You just have to add some nodes like train boxes. In train in malgadi in malgadi you are having some boxes now. Malgadi train, you are having like these boxes, engines that are connected to each other. Linked list is appearing like this. Okay, you can easily add some block, because it's just about adding a block. You can simply insert a block here, and you can use some other thing that is called vectors. These are the dynamic arrays. Dynamic arrays, okay, these vectors, we will be covering these vectors in the next session, because these are very important topic. These provides very good concepts that we can uh, automatically use, right? These provide so many inbuilt function that we can directly use when coding. So these are the dynamic arrays. So instead of using arrays, you can use linked list and vectors. These are flexible in nature. You can add many elements up to some, but it is also having some limit. But that limit is very after very that limit is very much. You can easily add newer elements. It is flexible. If your vector is containing 1 2 3 and you want to add a fourth element, it will accept that fourth element. It will not say okay, size is not given. No, nothing like that. Why? Because the size is allocated at the runtime. I will tell you this runtime and compile time in the next lecture, next to next lecture, when I'll be talking about complexity. Okay, when I'll be talking about time and space complexity, I'll be taking these topics. Okay, compile time, the runtime. So the solution of this is either use linked list or use vectors if the size of array is not uh, flexible, right? Okay, so what is the second application? So what is the second application? Arrays, sorry, not applications, not application, disadvantage, sorry, disadvantage, right? So what is the second disadvantage? See, it is disadvantage now, that's why I'm using red color, right? Okay, anyways, apart from jokes, okay, array is homogeneous. Array is homogeneous. Array is homogeneous. Array is homogeneous. What do you mean by this? There are two terms, heterogeneous and homogeneous. I think in science I have studied this kind of topic in chemical reactions, mixtures. I think I'm sure that you have also came across these two terms in chemistry, 11th and 12th chemistry. Heterogeneous mixture, something like that. Heterogeneous, genius, right? Heterogeneous mixture, something like, something like that. Okay. So array can also be homogeneous array is always homogeneous in nature, and the opposite term is heterogeneous, right? So for this lecture, we will be focusing on this point only, like why array is homogeneous, right? What do you mean by array is homogeneous? Okay. So now homogeneous means one type, just one type, no other types, no two types or three types or four types, no, just one type. It means array stores data of similar types, data of one type, or we can say, like when what do I mean by saying that array is homogeneous? It means it stores data of one type only. Either if this is an integer array of size 3, now you can only store integer values 1 comma 2 comma 3. If this is character array, now you can only store characters. This is suppose pqr. If this is float array, now you can store float values. Okay. It is not possible to store string in integer array. Okay, that's why it is called as homogeneous. Homogeneous means it stores only one type of data. Either all are numbers, that is integers, either all should be characters, either all should be float values. Float values. Your array cannot be something like this. Int arr, size is 3, and you are giving something as name, Karan, then comma. His marks are 98.7 percentage, and his age is 22. You cannot give like this. This is not acceptable, because array is not homogeneous. Array is homogeneous, it is not heterogeneous, that it can accept multiple data types in the same array. No, you cannot give string and float values in this integer data type, integer array, right? So it is not heterogeneous, but it is homogeneous. Homogeneous means store the data of similar type, one type. Homo means one type, right? No other mixtures, right? No other types. Okay, so this is really a problem for us. This is really a problem for us, because we want to keep students' records with multiple data types for one student. Suppose this is student 1, this is a student. I want to keep the record of his name, his age, and his marks, percentage in float. I cannot do it with some array. I cannot do it with some array. I cannot make a size of array 2 and store, okay, his name is Karan, his age is 22, and his marks are 98.7. Array cannot make it happen. That I can store this. This is the student array for the student, and it is storing these three things. No, array cannot make it happen, because array stores only one thing. Either you can store age, names, or marks. It cannot carry these three things simultaneously in one go. Okay, now this is a big problem, because for this student we want to store at single place three data types: its name, its age, and its marks. But it is not happening with this array. So how to overcome this issue? How to overcome this issue? How to fix or overcome this issue? Overcome this. You can create a structure. You can create a structure. Okay, like how it is created and what it is. This structure can store any different data types. This under one shed. Different data types can be stored under one shed, under one umbrella, under one name. Okay, under one name. Like array is not able to store under one name different types of data types. It can only store one data type, either integer array, character array, or string array, float array, like that. But structure can store different data types under one umbrella. This is umbrella, and here this is umbrella, and under its shed there are so many data types: integer, name, string, float, char, okay, double, long, like that. Okay, so like how to implement this. Let us quickly implement this. Okay, Let us quickly implement this. So for implementing a structure, like what you will do, you will write a struct keyword and the student, because you want to store the student data, no? Then curly braces with a semicolon. This is the student now whose data you want to store, multiple data. His name is string name, define it. Int roll number of the student, float marks of the student. Okay, array was not allowing you to do that, to store these three data types under one umbrella, but struct allows you to do that. Now int main, this is int main function. This is not written inside any function, it is written openly, right? Now this is int main. Now write struct keyword here again, write the student and create object. Write something like small s, and you can easily give all of these three things. You can give some name as Karan, you can give some roll number as 28, you can give the marks as 98.7. It is allowing you to do that. You will not get any error. You will not get any error. Okay, it is allowing you to do that. And how to print it? Something like that. S dot, cout s dot name, cout s dot roll number, cout s dot marks with object dot. This is object. This is some template that you have created, and any student can access that. Suppose there are 50 students in class, they can use this struct and they can provide their own details. Suppose the student one name is Karan, 28 and 97. Another student name is Varun, his roll number is 31 and his marks are 65. Third student came, it will access these three values, it can access, like, okay. So this is some template where whose this is some template and anyone can access it. Okay, so this is structure. We can cover this topic later. This is some simple thing that I have shown you, like how to overcome that problem, that when you have to store multiple data types for a single person or thing. Okay, so we will not be going very deep in it for now. This is student, this is structure. Okay, so just I have shown you like what alternate solution you can have for the same problem. So this is a solution. That's why I have shown you this structure. Otherwise, it is a later topic, right? Okay. So this is how we overcome the problem of array being homogeneous, right? Array being homogeneous. Fine, fine. Now another disadvantage is array has contiguous memory. Contiguous memory. Array has contiguous memory, and sometimes it gets wasted. Suppose I'm creating an array of size 5 here. Okay, suppose I'm creating an array of size 5. Suppose I'm creating an array of size 5. Okay, suppose this is 10, this is 20, and I have created an array of size 5, but I have just given two numbers, number 1, number 2, and I have left 3 blocks as it is unoccupied. We can say unoccupied, right? So these 3 blocks will be getting wasted inside the RAM, because inside the RAM this array will be something like this, where these blocks is occupied, this block is occupied, this is unoccupied. So these are getting wasted, right? So these are getting wasted and we are not liking it, right? So yeah, these are getting wasted because memory is contiguous. Okay, so who can overcome this problem? Linked list can do. Okay, linked list can overcome this problem. How linked list can overcome this problem? Linked list is a kind of data structure in which the memory blocks are not contiguous. Like in array, the contiguous blocks are there, na? This is block 1, then this is block 2, this is block 3. In linked list, these 3 boxes are like this. One here, and one here. So memory is not getting wasted. Because whenever a block is created, it can occupy memory differently. Okay, suppose there are five blocks, five nodes of the linked list, five elements. So these five elements can keep itself at the far apart distances. Okay, but in array the space will be wasted if these five elements will not come. Because suppose earlier five elements suppose earlier five elements are there, and only two are getting the space in the array. Three blocks are getting wasted. But in linked list, if five if two like these two elements can be separately stored, there is no need of registering the size for these the next three elements, because they are not actually coming. They're not actually present. And when they will present, they will occupy a block on their own. No need to fix or pre book their spaces. Let me give you some example to better emphasize on this point. Let me give you some general life example, right? Let me give you some general life example. So let me give you some general life example. This is very good example about to show like how arrays wasting space and linked list is not, right? How arrays wasting space and linked list is not. So let us talk about some examples. Okay, suppose this is a school and your trip is going to Goa. Again, that Goa trip, right? Goa. And this is a bus. This is a bus. Be a me uh, don't feel like the diagram is very funny. Okay, so this is bus, this is school bus, and there are seats. This is conductor seat, this is driver seat, steering, and everything like that. This is gate where the student will take entry from. And these are the three seater, these are the four seater or four seater, these are the two seater, these are the four seater. Like four spaces are there, four persons can sit. Person one can sit, person two, person three, contiguous. These are contiguous, right? You know, na, like in bus the seats are contiguous without much space. Okay, these are the two seater, and there be in between there is a lane, right? These are again two seater. These are full seater, like the back seat of the roadways or some bus is full seater, na. That's why. Okay, now you are four friends. You are four friends who decided to go to Goa together. Four buddies. Okay, class buddies, class fellows, right? Friends. Now you two came and occupied this seat. He occupied this seat, he occupied this seat. And you reserved this entire block for these next two friends of yours. You are four friends, na? Friend number one, friend two, friend three, friend four. So you came and sat at the seat, and these two friends, for the seats for these two friends you have occupied here. This is occupied. This is okay. This is booked. Sorry, this is booked for these two remaining friends. Remaining friends. Okay, but you came to know that these two are not coming. These two are not coming. Then these booked seats will be wasted. Booked seats will be wasted because you have allocated the contiguous memory. These will be wasted. Okay, because occupy booked the seat for four, but two only came. So you two will be left unoccupied and wasted. But in linked list, na, in linked list, it is not happening. Like you are not pre-allocating the memory of size 4. It is not happening in linked list. It is happening at the same time. Like if some block will come, it will occupy some memory. If another block will come, then only it will occupy some memory. It's not like that uh, five block space are reserved earlier. It is not like that. That's why the space is not getting wasted. Whenever a node will come, it will have that his space at the heat of the moment. At the heat of the moment, right? At the heat of the moment. Okay, so that's why the space is getting wasted. But if it was a linked list, na, if it was a linked list, if suppose it was a linked list, it is not an array seats, it is not an array linked list, then it is not compulsory that you will book these seats for two of your friends. Any two persons can also come and sit here. Okay, because it is not contiguous memory. Any element can occupy this seat, any element can occupy. And then these two seats will be occupied by some other persons. So in this array no two seats will be wasted, because the array is not contiguously allocated. Array is not there, linked list is there. So this contiguous memory causes problem when some seats or some blocks left unoccupied, right? Some blocks getting left unoccupied, right? Okay, So you can use linked list at this point of time when the contiguous memory allocation is wasting some space, right? Okay, now the last we have came to the last part of the video, last topic, that is insertions and deletions in array, like how insertions and deletions in arrays happening, right? This today's video was mostly theoretical, and we will be covering more and more difficult high level questions on arrays, don't worry. But I felt the need of explaining some theoretical concept in between, like array disadvantage, so that you can know more about arrays and know where to use them, where not to use them, right, where to avoid them, right? Okay, so that is insertion and deletion in array. Insertion in array, let us talk first about this insertion in arrays. Let us first talk about this concept. What is the concept name? It's insertion in arrays. Insertion in arrays, right? Okay, so suppose there are three blocks. There are three blocks. There are four blocks actually. One, two, five blocks in which some elements are there. Okay, okay. Suppose you want to insert this 10 element. These are some indices. Suppose you want to insert this 10 at second index. Now you will say this second index, okay, index number 2. You will say, what is the difficulty in doing that? Simply do like something like this, where ARR is the name of this array. ARR of 2 is equal to 10. You know, like what it will do? This line. If you will insert like this, this will override this 3 and fill a 10 here. And I don't want to do that. I don't want this 3 to be removed and 10 to be put. Yes, I want that 10 should be added at the second index, but I don't want at the same time that 3 should be deleted. Okay, this is not what I want. That 3 should be deleted. So this will not work. Can you think of any other approach, like what can be happening? Like, can you think some other approaches, like how you can insert? Because the size is full and you're deciding to add some more element. So you have two choices. I told you when the size is full, and then you have to add some more element. Either create a new array of some bigger size, like earlier you were having 5 blocks, now you will take 6, where you will transfer these elements here, 1 here, 2 here, 3 here, 4 here, 5 here, and then add this 10 at the back. No, add not add this 10 at the back. Let me show you this. We will be discussing it later. Note, because the insertion is not at the end, insertion is at the second index. Okay, okay, you will create a newer array of 6 size. Okay, 6 size newer array you will create, like 1 2 3 4 5 6. Or you can increment the size of this one more array by adding some block. This is the second thing. These are 5 blocks now, so you can add some block here by doing n is equal to n plus 1, right? Either resize or either create a newer array, right? Create a newer array, right? Okay, cool. Now how will you add this 10 at the index number 2? So let me resize this only. Let me take this approach. Okay, so let me raise it off, because we will be taking the second approach, where I will be flexibilizing, or I'll be increasing the size by 1. This is a name. So this int 10 is equal to 5 here, and I'm increasing its size by 1. I'm saying n is equal to n plus 1, right? I'm increasing its size by 1. Now the array will become like this: 1 2 3 4 5. Okay, the array will be something like this. I have increased one size. Now, oh, this is index number 4. Okay, now you want to insert 10 at the index 2. At the index is equal to 2. You want to insert this 10 at the index number 2, right? Fine. Okay, now one thing is you can add it here, but we don't want to add it at index number 5. We want it here. So what you will pick these elements one by one and shift it one location ahead. Remove this 5 from here, shift it one location ahead. One location ahead. See carefully what I'm doing. See carefully. Remove this 4 from here and shift it like this. Shift it here. You will put a 4 here, remove it from here. You're shifting the elements. Right? Now remove this 3 from here, put it here. Okay, remove it from here. Now you have seen that, okay, cool, the 2 become 2 index has become empty. Now this is the good time, you can directly put this 10 over here. This is the way. But like why it is a disadvantage of arrays? Because shifting of elements is a tedious task. Shifting of elements is a costly and tedious task. It is costly in terms of complexity, space and time complexity, something like that. Time complexity, because again and again you're shifting n elements. You have shifted some elements by one position. You have done something like this. The arr of I element, you have shifted this arr of I element to arr of I plus 1. It means one location ahead. So it is shifting of elements takes some time complexity and time, and some tedious, it is tedious task. That is why it is counted as disadvantage. Okay, because you are like you're shifting the elements, right? Like again I'm giving you some example. Okay, now you go to know like why insertion is a disadvantage, because it is disturbing other elements, like this is the bus, there is some seat, there is your friend, there is some aunties, some ladies are here, ladies, and this seat is empty, and you came to the bus and said, okay, uh, auntie ji, please shift one position here because I want to sit with my friend. Now this lady will be getting shifted to this seat, this will be getting shifted to this seat, this oh sorry, they will be getting shifted to this seat, they will be getting shifted to this seat. Now this will become empty, and you will come and sit here, with your friend in the journey. But this has disturbed two ladies, so elements like because they have to shift to adjust you in the middle. Okay, so that's why insertion is a complex task, so that's why it is counted as under the disadvantage, because it is taking big of and complexity to do something. We will be discussing complexity in the later part. Okay, now the last disadvantage is deletion in an array. Deletion in an array. This is also a tedious task. It is also taking big of and time or some complexity, because it also does shifting of elements. How? Let us see. Okay. Suppose this is array. There is 1, there is 2, there is 3, there is 4, there is 5. Now you will think that, okay, if 3 elements are getting shifted, what is the big deal? That was a small array. If the array size is of 1000 and you're shifting the element, you have to suppose the array size is 1000. This is array size, so on, contiguous 1000. You have to empty this block to adjust somebody, then you have to shift it from the 1000 element to this. See, 1000th element you are shifting to third element. See how many shiftings have been done. So that's why it is a complex task, right? So that is a disadvantage, right? Now you're clear, I hope so. Okay, now let us see like how this deletion in array is a liability, it is a disadvantage, right? Suppose I want to delete this element, so directly erase this element or put it over here, like override, simply override. This 3 will come here, this 2 will be overrided by this 3, this 4 will be coming here, this 3 will be overrided by 4, this 5 will be coming here, and this 4 will be overrided by 5. Now the final array will become something like this: 1 3 4 5. Now we have deleted, but still shifting of elements happens. Shifting of elements happens. So this is also a tedious and time consuming task, because you have shifted 3 elements, you have disturbed 3 elements. Same bus scenario. If you're going from here, then this is shifting here, because they are sitting in a very not so spaced way, right? They're sitting very close, those passengers, right? Those people in the bus. That's why when somebody left, then the space get free, they maintained some space between each other, right? So that they can sit, they can complete the journey with the relaxation, right? not too many occupied, not so occupied, right? Okay, so now you will say, okay, what is the big deal in shifting three elements forward? What is the big deal? It is not a big deal. Come on, it is not a big deal. Yeah, it is not a big deal for this array, but suppose if there are 1,000 elements, suppose there are 1,000 elements, and you have to delete this two. Now you will shift this person here, this person here, this person here, sixth person here, fifth, seventh person here, then 100th person at the this position. So you have shifted these many elements, like 1,998 elements. So this is a tedious and time consuming task. That's why deletion is not good, is not happened in a good manner, in a good way in arrays, right? Okay. So now let me code insertion and deletion for you, insertion and deletion. Let us move to the editor, dev c++ editor. So let us move to the dev c++ editor and perform insertion and deletion operations, right? Okay, let us move. Okay, so this was the editor, this is the editor, right? So suppose I am giving some array as 3 size, int arr n is equal to 1 comma 2 comma 3. So first of all, let us delete this 2 and put this 3 in place of 2, right? So how will you delete it? Like, how will you delete? Okay, so suppose this is 1 2 3 now, and this is 0th index, this is first, this is second. So you know that you have to put this 2 here. It means you will start the traversal or the loop from the second position, from the second index. Like, these are the three blocks. If you want to delete this now, then you have to start this loop from here, because you are putting it here, then you're putting it here, putting it here. That's why you have to start from that position next to the position that you want to delete. You want to delete this position, start from here so that you can put it here. Okay, so that's why I want to put something in place of 2, and 2's in the index is 1. That's why I'll start from second index, so that I can put that second to the first position. Simple as that. Okay, so what I'll do, I'll start from the second position, that is n minus 1. No, this second position. Suppose I'm saying you that index is equal to 1. So delete this index is equal to 1. So you will start from index plus 1 position, one after that. Okay, so that you can put the one after that position to that index, right? Okay, then I less than n, because you have to shift all the elements one position, all the elements after that. What do you mean by all the elements after that? Okay, what do I mean by that? Okay, suppose this is the array 1 2 3 4 5. Okay, this is 0 index, this is first, second, third, fourth. So if you want to delete it, you have to start your loop from here. Put this second element to the first index, put this third element to the second, put this fourth element to the third. Okay, so you are shifting till entire array na, this to this to this to this. Okay, so you will start the loop from this element. If you want to delete this memory, you have to start the loop from here, so that you can put it here. Okay, and go till end, right? So that's why I'm doing the index plus 1. I'm starting from it. Okay, so arr of I. So what you will do, arr of I minus 1 is equal to arr of I. Like, by this line what happened, like, by this line what happened. Let me take you to the editor. Okay, like, why what happened by this line. 1 2 3 4 5 0 1 2 3 4, right? So I'm saying that because you know that you have to put this second index element to the first index, you have to put I equals to 2 to the I is equal to 1 position. So that's why you are saying something like this: arr of I minus 1 is equal to arr of I, where I is supposed to, you are saying that put this arr 2 to some position which is arr of 2 minus 1, that is arr of 1. It means you are saying something like this: put this arr of 2 in the place of arr of 1. It means override this by this 3. Override this by this 3. It means override it by 3. Put a 3 here. It means 1. I minus means put the value at ith index to I minus 1. Yani ki it means one before. Okay, one before. If earlier it was a 2, put it 1 before 1. If it was a 3, put it 1 before at 2. If it was at 4, put it at 1 before. If it was at 1, put it at 0, like 1 before, 1 before. That's why I minus 1, in I minus, at I minus 1, put that ith value, right? That's why I'm saying error of I minus 1 is equal to error of I. It means this value should be at this place. Okay. Now after coming like this, you have to delete the size. You have to not delete, actually you have to do n is equal to n minus 1, because you know na, like after deleting this value, then your size decreased by 1, because earlier it was 3 elements, let us say, and you are deleting it, you are putting this element here. So it will be something like this 130, because this was left empty, and I told you already that when, okay, let me erase and explain this point clearly. Not in the corner, actually, this is main point, right? This is important. Okay, so this is 123. If you are deleting this now, you will shift it here, and by doing it will become something like this, but this will be left in unoccupied, because the 3 where the 3 was placed initially now, that will become empty. And I told you that when some space is empty, a 0 will be placed automatically by default in the array. Okay, so you don't want this 0, so just delete the size by 1. Okay, earlier the size was 3, because the elements were 1 2 3, but now when 2 is deleted, your size become 1 and 3. It means 2. It means subtract 1 from the size, because the you have deleted one element, then free the size for it. Okay, so let us run it off and see like what will happen. Let me run this code. Ooh, it is giving you 1 3. It means 2 is deleted, right? If I was not doing this, na, n is equal to n minus 1. Let us see what will happen. It will be 130, because the memory is still there. See, oh, okay, it is 133. Okay, it is 133. Right? It is 133. So whatever it is, it means this block memory is not getting deleted. When it is shifted here, na, when it is shifted here, you know, like why it is 133? Why it is 133? Because you have not actually shifted it here, but it is said that you have just changed its value, override its value with the next element. Okay, you know, like why it is giving you 133, not 130. Oh yeah, I thought of something else, that's why I told you 130, but it will be like, you know, like by shifting of elements, what I mean by shifting of elements, what I mean, like it is 1 2 3 4. It means if I'm doing na, you will put this 3 here. It means here you will be having 3 only, but you are just overriding this also by 3. You're putting this 4 in place of this 3. Okay, this 4 will be here. If I'm saying na, you are erasing it from here, it is not actually getting erased. It means you're just overriding some previous value with the same number. If it is 1 2 3 now, and I'm saying that you will override this 2th value by 3, it will be 3 only, because 3 will not go anywhere, but the previous value also you have overridden with 3. Okay, that's why the answer is coming at 133. So it is very important, to delete the memory, otherwise the value will be, because we have deleted one element, that's why the size should be deleted by 1. Okay, now let us see about insertion. Right? By shifting means it is not actually getting shifted, but it is the previous value is getting overridden, right? Okay, I meant that, right? Now insertion. This is an array. Suppose these are the 5 elements. This is 0th index, first index, second, third, fourth, right? This is some 10, this is some 20, this is some 30, this is some 40, this is some 50. Fine? Fine with you? Right. Okay, cool. Okay, so now you want to insert something at the second index. But before that, you have to create some block so that you can shift those elements. Okay, by shifting those elements didn't mean that you have erased 50 and put it here, replace it from here, put it here. No, it means like you have also put a 50 here. You have also put a 50 here, right? Okay, okay, fine. So you want to put something at this second index. How will you achieve this target? How will you achieve this problem? Suppose I'm giving you 100 and I'm saying you add it at index number 2. Okay. So you will create one extra block. It means whatever the size is, if the size is 5, you will say size is n plus 1, because earlier when you was deleting, when you were deleting some element, you were doing it n is equal to n minus 1. Now you're adding one thing, then you have to change the size. I told you that there are two ways: either create the new array of size 6 or add one block, right? Okay, so it means I added one more block. Okay, so 50 will be here, 40 will be here, 30, 20 and 10, right? This is third index, this is fourth, this is fifth, right? Yeah, this is third index, right? So now where you will start the loop from, you know that you have to put it here, shift it here. It means copy its value, like put 150 here also, like things like that. Okay, you want to put this element here, you want to put this element here, you don't want to put this element here because you want to free this space now, that's why you're putting it here. So you will start the loop from that position, that fifth position. No, that fifth position is not, that fourth position. Okay, because you want to put it here, so you have to start the loop from here, the element where you want to start, like you have to start the loop because you wish to start putting the elements from this fourth index. Then you are putting it here. Where you will go up to this second index, because this second index value you want to put it at third index and free this memory, free this space, right? So let us achieve this also. Suppose I want to put something at first index, and now this, in this array you can see that there is 2 at the first index, right? So index 1 I have to put something, so I'll start the loop from last element, n minus 2 basically. uh, n is equal to n plus 1, right? N minus 2, it will go up to that index value, index, and it will do a I minus minus. Okay, now instead of this I minus 1, I am doing a I plus 1. It means because I am putting this value 1 ahead, this value 1 ahead. If it is at third index earlier, I am putting it at the fourth index. That's why I plus 1. At I plus 1, this I will be putted, this I will be put, right? Getting stored, right? That's why, right? Okay, now error of I plus 1 is equal to I. Let us run this code and see like what answer we will get. Oh, we have not given anything to store. Okay, so it is coming at this. It is coming like this. I purposely did that because I wanted to show you something. If I am like, by doing this now, I have given you like this, okay? This 0, 1, 2. And you have created some block here. When you shifted it here, shifted means that you overrided this by value 2, but this value will be here only, right? So this is that's why the answer came something like this, because I actually moved this value here and overrided it here. This is become freed somehow. I'm free to override this value. It means I can override this value. Previously, if I would have overrided this value now with some 100 value, then it would be something like 103. This would be the array, but I don't wanted to delete it this 2 value. That's why I shifted 3 to come here, then 2 to come here, then this will be 2 only. Now I can override. If I override this value by 100, now it will become something as 123. So I forgot one step purposely. So what I'll do, I'll put ARR of index is equal to 100, because assuming that now you can override that particular value. Okay, it is coming as 123. Now you know like what happened. Let me explain you this thing clearly and then we will be winding up with the session, right? Okay, this was 1, 2, 3. Pay attention to this logic, right? When I'm saying na shifting, it means 3 is coming here. It means 2 is coming here. It means this value is getting overridden by 2. It is getting erased by 2. It is getting erased by 2. Overridden by 2. Okay. When I'm saying you will, this value is overridden by 2. Okay. Now this will not be empty. This will not be like this. There will be still a 2. because this value is just overridden by this. The 2 is not actually replaced from here and shifted to its next. No. When I do something like error of I plus 1 is equal to error of I, no, it is not like actually this element is erased from that position and gone here. It means just this value is overridden. It means overridden. Overridden and replace have differences. Okay, you're not deleting the value. Okay, if there is some value at index number 1 and you are saying na error of 2 is equal to error of 1, it means this value is getting overridden by 2, but this value is not erased at the same time. If you are putting this first index value to the second index, it means you're overriding, you are overriding this value of second index, but still there is value 2 at the first index. This is not getting deleted. Okay, this is not getting deleted. When I say no, this shifts to this is still here, but one copy is also generated here at the next position. Suppose it is 1 2 3, I'm saying that 2 will come here, 2 shifted here. Now this become 2, but 2 is still here, 1 2 is still here, right? It is not actually deleting, like we are not actually deleting it from here and putting it here. 2 will be here also because this is the actual position, this is the shifted position. Now I want to discuss something, right? Now I want to discuss this algorithm, like how it worked, how this insertion worked, how 1 2 3 converted to 100 2 3, how it is converted to this is zeroth index, this is first, this is second, this is 0 1 2 3, something like that. Okay, so I told this, I created an extra block here and I did something like this. I shifted, again I'm saying shifted means this is filled with 3, but still there is one 3. Now I shifted this here. It means this value of 3 is overridden by 2. It means some 2 will be getting stored here. But now here is 2 only. Now I can easily store error of 1 is equal to 100. I can easily override this value. I can easily this override this value and this will become like this. This will become like this. Right? Okay. So this is how actually it worked. This is how actually it worked. If it was 1 2 3 and I want to put 100 at this position, if I would have done it earlier na, that error of 1 is equal to 100, then you know what happened, this 100 will be directly getting overridden by this 100, this 2 will be directly getting overridden by this 100, and it would have become 103. But I don't want to delete this 2, I just want that this 100 is added in front of this 2. That's why I want to keep the 2 plus I want to add the 100. But this way I can add 100 but at the cost of deleting 2, overriding 2. That's why I shifted one index after, so that 2 can be still in the array. And I can easily override this 2 with the 100 because 2 has already present here. Okay, because 2 is already present here. Now I can freely and independently override this 2 value. It will become something like this. Okay. So this was the overall concept about arrays. I hope you have gained much knowledge from this video about like where to use arrays, like how arrays are bad and good and everything like that. Okay, applications, right? So this video was most about the theoretical concepts, and we have performed insertions and deletion operations, right? Okay. So we will be coming up with more and more high level questions on arrays as we will proceed in the upcoming sessions. You know, like why like most of the questions of arrays require some other data structure like map set. That's why these questions are not like I'm not able to cover these questions for now, because firstly I have to cover this prerequisite concept so that I can use these concepts in this array. Otherwise, if I directly using it, you will not be getting aware and much familiarity. That's why the prerequisites needs to be covered to do hard level questions of these arrays, because these hard level questions require some other things. So I have to cover these other things first, right? That's why. But now, and we will be coming up with the vectors in the next lecture. These are the dynamic arrays, and I will show you like how it is a benefit and asset for us. These provide some inbuilt functions that we can use as it is in competitive coding and coding company questions, lead code, GFG, like that. Okay. Okay, solving questions on coding platforms, right? I told you something one day, like if this was the question, and in some part it is requiring some inbuilt function, then you can use this small inbuilt function provided by vectors. Here you can use, in order to like I told you, like where you can use the sort function. When it is asking you that you have to sort this array, then you have to manually do it using insertion sort, selection sort, merge sort. But when the question is not about sorting this arrays, question is something else, but some part, at some small part it is expecting you to sort, then you can simply use this sort, because the main question is not sorting, it is something else. But at some point of the program you are requiring sorting, that's why you cannot, don't waste your time on sorting by manual, you can use inbuilt, right? This is the actual logic, right? Okay. So I hope you have enjoyed this session and gained much knowledge about arrays and its theoretical concepts. So this was all about the array. I wish you all the best. Thank you for joining in. Okay. So thank you for joining in. Have a nice day. Thank you.